output, and then a DC buck converter, powering the Raspberry Pi or the Arduino. If you've been following me a while, you probably know I'm the type of guy I like to...
Hi everyone, welcome back to another video. Hope you're all well. So in the last video we did this LED spinning gyroscope. I kind of destroyed it a little bit, but to be honest it still works fine, and I'm hoping that in future I'm gonna fix this somehow. But yeah, so moving on, another kit. So I bought a bunch of these kits. So in this video we're going to be going through an amplifier board, which is uses 12 volts to amplify. Now you might ask, what does it amplify? That's a good question. I don't know. It says TDA7297, which is this thing, I assume. What does this thing do? I don't know. So like I said, the purpose behind me buying all these things is so that I can learn. And so the hope is that, I'm going to learn and you're going to learn alongside me. And yeah, I have no clue what this circuit does. So what I'm going to do is I'm going to build up this circuit by... Let's first line all these pins. But yeah, I'm going to solder this circuit together and then let's try and fix these pins. Once we've soldered it, we'll jump on the computer and do some research, figure out what this does, how to use it. After that, see if we can apply some modifications. So I got almost all of them in except this one pin here. And yeah, for me, this is the best way for me to learn. I love learning by doing. And so, I don't know what this kit does, but the fact that I've got my hands on it now, it's going to make my process of learning so much easier, versus if I was to just start researching about it myself. I wouldn't have really gotten anywhere like that. So yeah, that's why I do this. Nope. My soldering skills, they truly suck, and this is one of the reasons why I do these videos, so that hopefully I can get better at it. Basically what happened was I had a bunch of problems yesterday doing this one, so I changed my solder tip to this big solder tip, and yeah, I don't think it's done me any favors. Alright, so this isn't working out for me at all. Like, I'm just getting huge solder blobs. This tip is way too big, so I'm gonna have to turn it off and replace the tip for a smaller one. It's gonna take a while to shut down, so we'll be back in a bit once it's cooled down. To be honest, it's gonna take probably 15 minutes before I can touch it. Alright, so it took some time, but I've switched over to the new tip now, or the smaller tip. So let's hopefully... The thing is, I can't hold this because it gets too hot. So I just need to try and fix up all of these poor solder joints because they're all just kind of like joined together. Okay, and then there's like 2 pins here that aren't really done properly. I joined. That's pretty okay. I mean, the joints themselves are not the best at all, but they're quite bad actually. But I think that'll do. Now, this plate is boiling, man. I don't know. I assume this is by design, but bloody hell, man. It's hot. Alright, let's see what's next. I don't really even know, to be honest with you. Let's look at the pictures. Okay, so you got 2 capacitors, the 2 bigger capacitors in the middle, but they're kind of different sizes. Where's the diode go? Okay, the diode goes here. So let's put this diode in. Oh man, this thing is hot. Alright, so we'll do the resistors next. These are just 2 of the same resistors. So just keep in mind, I have no idea what this circuit does. I'm just soldering it just to try and get better at soldering. So I was just about to solder that side, and I realized more than likely the resistors have come loose. But in this instance, they haven't, thankfully. So I should just be able to just solder this side as well. No problems. Boom, that was the simplest set of resistors I've done in a while. Alright, so let's do these smaller capacitors now. They just go in here. I've literally got no idea what's going on. It looks like that's like the positive terminal ground. This says TN1, TN2. I really don't know. Plus 12 volts there. Oh, and then you got out as well. Okay, so you got 2 inputs and 2 outputs. So because it says that it's an audio circuit board power amplifier, I assume it's amplifying sounds, but I don't know that. I've studied amplifiers in uni, but I must say, as for the actual like circuitry behind it, I got. Alright, that was an interesting way of doing it. Yeah, let's try and push this down. Okay, they're kind of flat. It's getting hot. Okay, so those are done. Alright, and then we just got the 2 capacitors. This one is 100 microfarad, which I assume I'm going to go there because it says 100U there, and this one says 10U, so I assume this is a 10 microfarad. Yeah, this is a 10 one. So that goes there. That goes there. Just need to be careful when it comes to heating up capacitors, but it should hopefully be fine. Let's just put some flux there to help myself out. I found some success in doing it this way. Alright, so this is nowhere near my best, right? I mean, obviously I could do better, but it's not my worst. And I think, I took 6-8 weeks away from it, and I did my first one yesterday with this, and this was obviously terrible. So this is, I think, it's getting better. Definitely not the best, but from what I can see, none of them are touching, so there shouldn't be any shorts. Some of them are a little bit close, but I didn't burn the PCB, so yeah. I mean, this, I don't know what it is. We're gonna have to jump on the computer and figure that out now. We have to figure out what this TDA7297 is used for, and figure out what an audio circuit board power amplifier is. So yeah, I think I'll set a goal to try and use this. I don't know how I'm gonna do it, but let's give it a go. So let's jump on the computer and figure out how this works. So it really sucks that the kit didn't come with any instructions, and the listing that I bought this from has actually been taken down. So what I've had to do, I've actually just Google it. I actually managed to find another AliExpress listing, and it had the following stats, which I believe is the exact same as this. So we've got a supply voltage of 12 volts with a max of 20 volts, an output peak current internally limited to 2 amps, and a total power dissipation of 33 watts, which is its max. Operating temperature of 0 to 70 Celsius, which I think is going to end up going a lot higher because I don't have a radiator, as I'll mention in a minute. Power 15 watt per channel, which is how you get the 33 watts. And then one TDA7297 amplifier board DIY kit, which is obviously this whole thing. The TDA7297 is this black chip. Now, it says here, note, and I didn't see this. Note, device requires a heatsink to operate, not supplied. So they didn't supply the radiator that you need to attach it to in order for it to operate. I've seen pictures of it working without the radiator, so I'm just gonna go with it, see how it goes. So yeah, just fine. I actually tried to search for them on eBay and Amazon and couldn't find any. So I don't know what people are attaching their heatsinks to, but yeah, doesn't matter. I'm just gonna skip it. So at this point, I still don't know what an audio amplifier board is. So I've gone on Wikipedia, I've looked at their definition, and it's good enough for me. An audio power amplifier, or power amp, is an electronic amplifier that amplifies low power electronic audio signals, such as a signal from a radio receiver, to a level that is high enough to drive loudspeakers or headphones. Pretty simple enough. So you take a tiny audio signal and amplify it up so that it could power speakers or a headphone. That's fine. So amplifiers are classified according to their circuit configuration and method of operation. So you see all the time there's this, class that amplifier. So there's two main types of amplifiers. The older and more classical type of amplifier is this on the left, which is a linear conduction angle amplifier. And the newer, more modern amplifiers are the switch wave shaping amplifiers. So you got Class A, Class AB, Class B, Class C, Class D, Class E, Class F, and you got G, S, T, etc. So yeah, there's a lot of them. This is basically my limit in terms of my knowledge of what an amplifier is, and I think this is good enough for what we're gonna do here. So when you look at the TDA7297, you might be wondering, what type of amplifier is this? What I did was I googled TDA7297 and I found this guy's great website. His name is Dan, Electro Dan, and he has some really good information on TDA7297. So I'll just read what he's got on his website here. He's put, the TDA7297 is a best-selling amplifier chip. It allows you to easily build high-performance stereo amplifiers, power supply of 6 volts to 18 volts single supply, and it's a Class AB amplifier. So now we know what type of class it is. The TDA7297 is a simple to build stereo dual amplifier that can deliver a rather good amount of power into 8 ohm speakers from just a single rail power of 12 volts, and even more power when supplied with around 17 volts. So I'm not sure what speakers I've got here, because obviously this kit didn't come with any speakers. So I've got these speakers which are taken out of a laptop. I don't know if they're 4 ohm, I don't know if they're 8 ohm, I really don't know at all. I've also got some other speakers which I just got. They're actually car speakers, so if it can't drive this, which I don't see why it wouldn't, because these are small speakers, then I've got much larger speakers, but that doesn't really make sense. So the application is intended for TV and portable radio applications, but has a wide range of possibilities. The datasheet only has statistics and information about performance into 8 ohm speakers, so this is an important point. However, the amplifier does appear to work fine into 4 ohm speakers, but performance is unknown and expected to be worse. That's because the TDA7297 is bridged, and therefore 8 ohm speakers look like 4 ohm speakers to each individual amplifier inside the chip. Therefore 4 ohms will look like 2 ohms. If driving 4 ohms, I would recommend the power supply is kept below 14 volts. I found it to be happy into 4 ohm speakers on a 12 volt power supply. So I'm going to stick to this 12 volts because obviously we've got 12 volts here anyway. So yeah, we'll go with that. So looking at this schematic here of this TDA7297, I don't understand much. I mean, I can see we've got 2 outputs here, one for the speaker 1 and one for speaker 2. And then we've got 2 inputs here, input 1, IN1 and IN2. So yeah, I'm guessing here we've got TN1, TN2, which is going to be our inputs. And I'm actually even thinking, if you look at here, perhaps the T is actually supposed to be an I, but it wasn't able to print onto the end of the circuit board. I mean, that's probably, there is actually enough space there to print. So yeah, I don't know what happened there. You can see the bottom of the 1 fine, and 2. But I'm assuming TN1 and TN2 are the inputs here. But I don't know, maybe not, who knows. Another thing that I've found is that when I was looking at the data sheet of the TDA7297, then it gives you some information here about how to use it with a microcontroller, and it mentions that ST by is short for standby and mute is obviously mute. But since I'm not using a microcontroller, then I figured I don't need this part. But it does then go on to say low cost application. In low cost applications where the MP, which MP stands for, I assume, microprocessor, where the MP is not present, yeah, so the microprocessor, the suggested circuit is shown, and then they put some figure circuit, I don't know. The ST and mute terminals are tied together and they are connected to the supply line via an external voltage divider. So this is interesting. So I'm thinking here, we've got this jumper cable. This jumper cable is probably tying together this ST by and this mute function. And then it's probably dealing with this voltage divider between these 2 resistors. That's what I'm thinking. I'm not 100%, and I think if you know, please correct me. But I think that's what that jumper cable and these two resistors are doing. I think they're acting as a voltage divider. All right, so that's enough guessing for me. Let's move on to, I suppose, what a Class AB amplifier is, right? So obviously, whilst I was reading about the TDA7297, then the Class AB amplifier was mentioned. And I've actually heard Class A amplifier, Class B amplifier, Class C amplifier. I've heard that mentioned a lot. So I wanted to have, like, at least some sort of shallow knowledge on it. So according to electronics tutorials, a Class AB amplifier output stage combines the advantages of a Class A amplifier and a Class B amplifier, producing a better amplifier design. So that obviously leads to the question of what is a Class A amplifier and what is a Class B amplifier. All right, so I'm just going to touch on Class A amplifiers in a light way because I found it to be quite complicated. So yeah, don't shoot me here. If I'm making mistakes, just drop it in the comments, please. But a Class A amplifier is, generally speaking, the most common type of amplifier. And it just uses one output switching transistor, which I think is a good thing. And they're considered to be the best class of amplifier design, mostly due to the fact that they have a high gain and low signal distortion levels, which makes sense, right? Now, they are hardly used in high power amplifier applications because of their thermal power supply considerations. I assume they heat up quite a bit. So Class A amplifiers are probably some of the best sounding amplifiers out of all the different amplifier classes. So a Class B amplifier is actually the opposite to a Class A amplifier, whereby basically they're focusing on sorting out the efficiency and heating problems that come with a Class A amplifier. So in a Class B amplifier, there's no DC based bias current. So that means that the DC power is small and therefore its efficiency is much higher than a Class A amplifier. So apparently Class B amplifiers are super efficient, but they're not as good quality as a Class A amplifier. So then that brings us on to a Class AB amplifier, which is what we got here. That would be one of the most common types of amplifiers used in audio power amplifier design. And I think a Class AB amplifier takes the sound quality of a Class A amplifier and tries to get it to be as efficient as a Class B amplifier. So again, I mean, how much is that going to help? For me, it's helped quite a bit. At least I feel like, I kind of get it that, this little thing here is a Class A amplifier here and a Class B amplifier here coming together to make one Class AB amplifier. I feel like when I'm watching some of those YouTube videos now, I won't be so entirely lost. So I'm happy. All right, so let's move on. So the fact that this kit didn't come with a schematic is not great. So I'm having to guess quite a bit. But if we look at the inputs on the board, there are 5 inputs, right? So you can see here, these 2 big circle ones are not inputs. So if you have a look here, you can see that there's the tracing around these and obviously nothing around there. So these are just mounting holes or whatever. So we've got positive supply, which is going to be 12 volts. We've got ground here, which is going to be ground, and then here as well, which is going to be ground or negative. And then we've got TN1 and TN2. So to me, the only logical conclusion, and again, I'm just guessing because I don't have the instructions, would be that this TN1 or TN2, or if it's indeed IN1, IN2, in1 or in2, is going to be where like the audio signals from a jack, an audio jack wire comes from. So I'm thinking if I take an audio cable, like, from a speaker or whatnot, or from, I don't know, a USB to jack, I'm not sure. But if I cut it, I'm assuming I'm going to have 2 wires that I'll be able to just stick into TN1 and TN2. So to confirm if I was right, I actually went and found a bunch of images on the internet of people that have made this kit and how they've done it. And from what I can see looking at the pictures, although they're a bit grainy and not the best quality, it seems like, some people have had 3 cables, which I assume is going to be VCC, ground, and then, just 1 input. I'm not sure. But yeah, it's a bit tricky to be able to make a decision and tell based upon the pictures. But yeah, I think my assumptions are right. I'm pretty sure if I cut an audio wire, I'm going to have 2 wires and I can just solder them into TN1 and TN2, I think anyways. And then obviously the output pins or the output ports are obviously obvious in the sense that it's just going to be speaker 1, speaker 2. The only thing that I found a bit difficult or challenging here was that here it's labeled positive and negative, but this side isn't labeled. And so I'm guessing that since it's not labeled, it's going to be the same polarity as this, and you're going to have the positive on this end and a negative on that end. And most importantly, I need to remember to add a jumper cable there along there. So let's do that now. Let's add a jumper cable here, and then let's also add the output to our speakers as well onto here, and then we can start dealing with the inputs here. All right, so we're back on the desk. Excuse the rain sounds because, you know, I live in the UK, and for some reason it rains even in July. So I'm gonna install a jumper cable across there because I need to do that. So let's do that first. All right, so I've put that jumper cable on there now, so we'll do that on nicely. So you might be wondering what the headphones are for. That's obviously to supply the input. So I'm gonna connect that to my laptop, and then solder this into here. But before we do that, let's add some more jumper cable for our input, so our positive and our two grounds. So yay. All right, we're getting better, I think. All right, so I've soldered them two on now. The holes are quite big, so they require a lot of solder, but the good thing is I should now be able to put another wire through there in that hole there alongside it. You can see there's quite a lot of space there, so I'm going to use this green wire for the ground. I don't know why I've used red here. That was a bit silly. Let's make it kind of nice and long. So my power supply is not. We'll make them two different lengths as well. Let's make the ground long. So this is where I'm going to be supplying the 12 volts. Okay, and I should just be able to just put that in there and heat that up, right? So if I just heat this up, I should be able to just push it. There we go. Alright, I think that's got a good connection right there. So they're both joined together, and then this is a nice solid ground. So let's just strip this end. There we go. Alright, so that's the ground done. So now let's just do the 12 volt. We'll just do it a bit shorter, not that short. So far we've added this jumper cable here, and then I've joined these two grounds together with this bit of wire here. Then I've got my ground cable here and my 12 volt supply cable here. So I need to add my speakers to here on the out, and then I just need to add my headphones here on the input. So the headphones I have a concern with, I'm not sure if they're going to have a common ground or not. So let's just, so this end is going to go so this end is going to go into the headphone jack of my laptop, right? So then the audio signal is going to come out of there and then come through these wires, and then normally it goes into these headphones, right? So I'm just going to cut it off here and then take a look at this wire. I could cut it here afterwards, but I'm not going to do that. I'm going to cut it off here. So if I just maybe cut it here, so I give myself enough room to repair afterwards if need be. Alright, and then so I've got like some rubber on it. I don't know. I don't even know what happened there. I've just tried to pull it out and I don't know what happened there. Alright, cool. So I think this might be a dud, I don't know. I've got some cables here, but what are these? Is this shielding or what? I don't know. Alright, let me take a look into, because I'm not going to be able to repair that. Look at that. This is some thin, this is obviously some thin, cheap headphones. I wasn't about to cut my expensive one, but let's take a look into this end here and see perhaps maybe it's shielding up until here and then just do normal wires here. So maybe I could determine what's what from here. Oh my gosh, this thing won't even cut. Headphones are tangled even after death. Right, so wait. So this left one here has a blue and a green. So my fears have come true. I think each cable has a ground. Yeah. So green and blue there. Green and blue there. And then, so probably it's like blue and red. And then this copper ground or something. Let's have a look at this one. But I don't know what I'm going to be able to do. Okay, this has all three. Bloody hell. But one might be like a data wire for the... Yeah, look, this is probably for the button, right? So maybe let's have a look at it after this point here. At this point, I feel like giving up. So let's see. We'll see how it goes. Okay, it's like even thinner. Can't really discern what's what. It looks like red. I don't know. Okay. Where do we go from here, people? This is not thick enough for me to connect this into here. I could try and order one online. Let me just see if I can grab something else. Alright, so what I've done is I've ordered an audio jack so that I can connect the connectors there. I'm pretty sure it's going to have a ground and then two inputs. So I'll put input into TN1, another one into TN2, and then one into ground. So I'm going to have to maybe make some room there. I don't know. But for now, I've got these speakers that I got from a laptop. So let's just cut them and attach them to the audio out. Oh dear, I just snapped my my tweezers for some reason. I don't even know why they snapped. That is some rubbish tweezers. Oh my days. Alright, go order some more of those. Ridiculous. That's the second pair of snaps as well. Alright, so those tweezers are rubbish. Alright, so we've got all this twisted cabling situation going on. So I don't know what is positive versus negative in terms of the coloring scheme. I'm thinking it doesn't make a difference with speakers, but I don't know that for sure. Suppose we're about to find out. That's quite decent. That's a decent connection right there. Oh, you know what? I might cut up one of my good speakers because I would like to get this tested tonight, man. I don't have to wait until tomorrow. All right, let's do this other speaker then. Hopefully polarity doesn't matter. So that's that speaker attached as well. So literally both speakers are attached. The connections there are not the best. I tried to put a bunch of solder on it. Connections aren't too bad. I think they'll be okay. So I just need an audio input now, man. I might try and cut some decent headphones. Let me try to find some. Alright, so I didn't manage to find a wire that I could use to cut up even expensive headphones. So I ordered some on Amazon and thankfully it came within the day. So this is a headphone jack, male and female. So I need the male to connect into my laptop so I can cut the female off. I'll cut it about halfway, so hopefully it's useful. Let's see what's inside. Please don't be too bad. Please don't be too bad. I mean, because it depends on the quality, right? Oh. Okay, so we've got interesting. Alright, can I strip some more? Yes, I can. So we've got a white, red, and black cable. I don't know what's what. The white appears to be different to the others, but I don't know. So let's do some Googling. Let's try and figure this out. Alright, so apparently this is the ground, this bit here. So you got left, right, and ground, or maybe it's right, left, ground, I'm not sure. But definitely this bit up here is ground. So I should be able to just touch this bit here on my multimeter to see where you get the short or you know, where's where, was what, I don't know. I don't know what the right terminology is there. But yeah, so I'm just looking for the short basically. So we'll touch it over here. Okay. Are they touching? Yes. Right, and then I'm thinking this is white one. Oh wait, I'm not on the right setting, am I? Select. There we go. Okay. So it's not the white one. So it's the black. So the black is the ground. Okay. So now the other two shouldn't matter, I don't think. Alright. Let's just, I should be able to test for which is which, so I don't think it matters. So this bottom one is the white one. Alright, so have a look. So if I touch it on the bottom part of the jack and then touch the white one goes off. So, alright. The left audio, I just looked at my computer, the left audio is this tip here, and that is the white one. The back bit here is the ground, which is the black, and then red is the left. So, alright, let's just strip these a bit more. Oh, so this is the input, right? So what we're doing is we're grounding this one here. No, so we're grounding the black one. The black's being grounded, and then the other two are going there. We'll do the ground first, which is the black one. I think we're in, but I think I've burnt quite a lot. Let's have a look. I think it's okay. I'm just going to try and apply some solder onto this end here to just try and tighten up some of those connections. But other than that, I think it's okay. Now, lastly, just for the left and right wires, which are quite hard to see, but these two wires here, just got to put them in the left and right. Okay, they're both kind of sitting there. I mean, I think that red one might have burnt away a bit, but other than that, I mean, it's okay, I think. Is that it? Are we actually done? Oh man, I hope so. Okay, so I think from here now, let's apply the 12 volts to the circuit first, just to make sure there's no capacitors exploding or whatever. So we'll do that, and then afterwards we'll apply. Oh dear, my ground has come out. Oh, alright, let's stick that back in. Alright, so I've stuck that back in, so now let's get my power supply set up and then try it. Alright, so let's give this a go. So if we stick it on 12 volts, alright, there we go. So we go ground, okay, and 12 volts, see what happens. Alright, is that the speakers? Yeah, both speakers making a sound. Okay, so my input is here. It's responsive. This is exciting. Oh, this is exciting. Alright, let me set my laptop up. Alright, so I've got a YouTube video here playing on my laptop. So let's see. This is the sound from the laptop, right? So I'm gonna just turn down the the voltage. I don't want to fry my laptop. So let me turn it down to a point where the speakers aren't so loud. Alright, let's pause this. So I've got it down to 7 volts. The speakers are still buzzing. My audio jack port is here. So, all right, it's acknowledge something. So if I say headphones and play. Whoa!
It's got an equalizer setting, which I can change the equal.
Whoa! It's working. Oh my! Let me try to pick a different video.
Hi everyone, I'm Hamid.
Oh, it's working, man.
Of any other ideas?
Woohoo!
I just settled on this idea after I did my last video on this, which you can watch
That's so
here.
loud.
I just thought, you know what, this is exciting. To make a renewable energy kit, whether it's based on the Raspberry Pi or the Arduino, it doesn't really matter. But to make a renewable energy kit that I can sell after I graduate on Amazon, on other websites, eBay, whatnot,
The current,
whereby somebody, hobbyist, a student,
the current's
is able
fluctuated
to
around
actually
quite a
take the
bit.
kit and learn how, you know, solar panels, wind turbines, etc. work on an electronics level. So let's get straight into this video. So I've picked my final year project. I've discussed it with my lecturer. So let's go through the plan. So first,
so the IC is getting quite hot. Yeah, the IC is getting quite hot. I mean, it's still warm enough for me to touch, but you can feel it getting hot. And this is on 6.5 volts. So this is apparently can take up to 20 volts. Let me just press play again.
First up, you want to find a gap in the market, and this is what came up when
I'll try to turn
searched
it down on my
an Arduino renewable energy kit. And literally, you know, I mean, you've got like some renewable energy stuff for
if I go
like
down,
5-year-olds. You've just got some random robots.
So 4 volts is still working.
And the same thing when you look on Google as well. There's a huge gap in the electronics
3 volts,
market,
still working. 3.5 volts
any
off.
sort of kit that could be used to teach renewable energy.
Let's go up.
In any sort of detailed way, especially on both an electronic component level and also on the Arduino Raspberry Pi level. There's just there's nothing, sadly. So this is where my final year project comes in.
So
Look at
I'm
that
not.
lovely design.
I don't want to go above 12 volts. I don't know. I mean, yeah. Let's go up to 14 maybe.
Yeah. So the plan is to make a kit like this. Just imagine a little box that you could open up, and
let me turn up the volume.
Some really cool things inside. So the full kit will have, you know, PCBs, components. So the PCBs, I've designed them myself. Literally CAD files.
Do you see what happened to the current there? Watch, I'm going to increase the volume again. The current spikes from 40 milliamps all the way up to 1 amp.
Get them printed, and then have all the components as well sourced, put them into individual kits, and then the user would actually develop and build.
Even there, it jumped to 1.6 amps. Bloody hell.
Charge controller, a DC to AC inverter, and also a buck.
Yo, it's hot.
The plan is to include a small solar panel in the kit, and then possibly set an up.
Let me go down to 6 volts again.
And also include the battery. So if you have a look over here, this is kind of what I have in mind, whereby I could ship the kit.
Alright, so we're at 5.6 volts. Let me increase the volume. So now we're at 30 milliamps, right?
Using my tutorials, they can build together a whole DIY kit of a charge controller, of a buck converter, etc.
So it didn't even go above half an amp. So on a higher voltage, it ends up going way over 1 amp, 1.6 amps. So up to here.
The students done with the entire kit, putting the whole thing together will create, you know, a solar panel that generates electricity.
Mate, bear in mind these speakers came out of a laptop. I broke them out of a laptop. They're good, man. Really good speakers. Or are they from a laptop? They might be from. No, I'm pretty sure they are from a laptop. Or they might be from like the HP computer, the touchscreen One Touch that I had. But I think they're from a laptop. But I'm amazed. I cannot believe that this little thing here, it's actually not even that hot. That's actually okay. It's working so well.
DC output, and then a DC buck converter powering the Raspberry Pi or the Arduino. If you've been following me a while, you probably know I'm the type of guy I like to.
I mean, that is amazing. I cannot believe it. So you've got a small audio signal coming into here, and that's just crazy. That is absolutely crazy that somehow having a small audio signal entering here into these wires is getting amplified and coming out in the speakers. That is amazing. I think understanding and learning how this kit works, you know, on a pure electronic level is probably outside. It's probably outside my scope of interest and level. I think I would have to do a lot of reading to be able to grasp this. But man, like, I'm surprised with how hot it gets that the solder didn't melt, but it seems to have been okay. I'm amazed, guys. I'm absolutely amazed. You know, think about the start of this video. I didn't even know what this kit was. And now somehow I've built this contraption. Man, look, you know, I must say, I really, really, really am enjoying these kits. They're just cheap. They're really cheap electronic kits. And I just ordered a bunch and I had no idea, literally no idea what any of them did. I just thought, you know what, 50p a pound, £2, £3, you know, for a kit, it's fine. Let's just order it, see how it gets on. And I never would have bought this, if I'm honest with you, never. But this is amazing. We'll wrap this video up here. And, you know, in future, if I get time, I'm going to put this aside. This is a brilliant kit. I'm very happy with it. I would love to try and expand on it. That would be amazing. If I do expand on it in future, I'll come back to this video and leave a comment in the description. Leave a comment down below and let you guys know where the next video is. But man, this is, you know, what is this 70p kit? I didn't have to buy a radiator for it. I'm amazed. I did spend a £1 on this audio jack, but again, yeah, loved it. Absolutely loved it. Full on plus like from me, thumbs up for me, and I'm going to jump on AliExpress and leave a nice review. This is amazing. Alright guys, thanks for watching. I love this. Yeah, I'm speechless. Thank you.